All right. So scientific notation. I remember this from last year. You guys did pretty well with this. All right, there. That's what I was looking for. So with scientific notation, we're going to jump kind of right into it. All right. With these, they just show us rewriting them. All right. They want to rewrite us to greatest to least, and that's going to help us. All right. Orders of powers of the bases. Learn to express large numbers and small numbers in scientific notation. That's what our goal is today. What is of super importance today when we're doing scientific notation is the thing called a decimal. That is important. That's where we always go to start. We always go to the decimal. Okay? And the reason we always go to the decimal is with the decimal, it will tell us what we have to do. All right? All right. Scientific notation. That is the only thing that we're looking and learning about today. Now, an ordinary quarter contains about this many ginormous number of atoms. That would be a very long and hard number to write out, making sure you got all the right number of zeros. All right. The average size of an atom is about this number. Lots of zeros, then after the 3 centimeters across. So we want an easier way to write these numbers. Another place where they use scientific notation is when they're talking about space and the distances across space. So the length of these numbers makes it awkward to work with. Scientific notation is a shorthand way of writing such numbers. Okay? Numbers written in scientific notation are written as 2 factors. So there are actually 2 numbers we have to write when we're doing scientific notation. One factor is a number greater than 1 and less than 10. So that means any number that has one number ahead of it and a decimal and then other numbers. All right? No matter what I write, if there's only one number ahead of it and then other numbers, it'll be between 1 and 10. So the decimal always goes one place with one place to the left of it. Okay? There's always one place to the left of the decimal when we're doing scientific notation. The other power the other factor is a power of 10. Oh, times 10 to the, that's a 10, third. All right? So you have to have both of these parts for it to be scientific notation. Okay? Now, with scientific notation, we start off big and bold, and we're going to write it into standard form. Now, do you guys remember 12 times 10? Well, what is 12 times 10? Can you tell me, Lucas? 120. How'd you get to 120 so fast, Lucas? Oh, you just put the 0. Do you know what you actually did? With 12, there's a decimal right here. There's 1 0 in 10. Move it one spot, put the 0 there. The reason I really harp on the decimal is when we multiply by tens, we can move the decimal right. What do you think we do if we divide by decimals? Do we move the decimal right or left? Left. So we've got to think of this number. 1.35. Okay? Now, that's what we're going to start with, and I'm going to stay right there. But now I've also got to deal with this, 10 to the 5th. Does anybody know what number 10 to the 5th is when I multiply it out? How'd you get that, Carson? Why did you put 5 zeros? You did it exactly right, but why 5 zeros? And if you remember our conversation from last year, the power there, do we see that? The power tells us how many zeros there should be. Hey, so I'm multiplying 1.35 times 10 to the 5th. There's 5 zeros. How many times do I move the decimal place then, Carson? 5 times. Oh. 1 spot, Lucas. 2 spots. 3, 4, 5. Now the decimal's right here. What do I do with these blank spots, Carson? Oh. So the decimal is way at the end there. So are those zeros important, Carson? Yeah, they are. Super important. The decimal is way to the right here at the end. So that's important. So 1.35 times 10 to the fifth turns into 135,000. The 5 tells us how many places to move the decimal. So we always start at the decimal, move it 5. Now it's a positive 5, positive exponent, so we move it 5 to the right. If it's negative exponent, we move it 5 to the left. So if you see down here their helpful hint, positive exponent means move to the right, negative exponent means move to the left. Right? 5 places. Hey, there we go. And notice they started right here where I put that decimal in there because that's where the decimal was. So with this one, we're going to look at 2.7, crew. Are you with me, crew? Awesome. 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 All right. Now, we look at this. It's a negative exponent, okay? So we're going to take their word on it. What did the negative exponent mean? Did you remember? Oh, you can? So we could think of it as 1 over 10 to the third, okay? So that's saying division. So if we divide this, or if we think of the negative exponent, that means move it to the left, okay? With a negative exponent here, the shortcut trick is move it to the left. So how many spots to the left, though, crew? 3, because the exponent is 3. 1, 2, 3. Now the decimal's right here, all right, Christine? We put zeros in to fill in those loops. Do we see how the number got smaller? 0.0027. A negative exponent will make you get a smaller answer. A positive exponent will make you get a larger answer when you're going from scientific notation to standard form. Okay? Where do we always start, Haley? At the decimal. The decimal is the key to all of this. So let's look at their work. All right. So it's like dividing by 1,000, crew, okay? That's why the 10 to the negative third is moving it 3 to the left. It's like dividing by 1,000. All right. So divide by the reciprocal, okay? We move that 1, 2, 3, 4 spots. They started between the 2 and the 7 because that's where the decimal was, and we put it into a new spot, making the number smaller. All right. Now we're on to this one here. Gavin, you there? Oh, yeah, he's had the mic problems. Christine. All right, Christine. So we have 2.01. So, first of all, Christine, looking at the exponent over here, is the number going to be bigger or smaller when we're done? Bigger. Okay, go ahead. All right, bigger because it's positive. You move the decimal 4 places to the right. I'm going to change to red before I do that. 1 spot. Make sure you go up between the numbers. 2 spots. 3 spots. 4 spots. How many zeros do I have to add, Christine? 1, 2. Okay. So our number did get bigger. 20, 20,100. Oh. So when we have that positive one, there we go. Okay. Let's look at their work real quick. Yes, times 10,000. They start there. All right. Trent. Oh, who's that? Trenton. I actually was going to call on you on this one. That's awesome. Well, I can say that and doesn't really seem effective, but Trenton. So what do we do on this one, sir? Is the number going to be bigger or smaller when we get done? Right. How'd you know that? Positive. All right. What do I do, Trentone? How many times? 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, the biggest problem you guys are going to have is you're going to get off on your loop-de places, as Trenton said it. So I do want to show you something that if you're worried about your loop-de places, you can do this. So we get 2, 8, 7 with 1, 2, 3, 7 zeros. 1, 2, 3, 2, 3. So we get 2,870,000,000, and then Trenton can buy his new Hummer. Pocket change. All right. Now, how did I know to write 7 zeros? Well, the first thing I want you to look at here as you kind of work with me, Trenton told me to start here. 1, 2. So, then that means there's 7 spaces left, right? Lucas, is what you're saying? Yep, there's 2 spaces. After I go 1, 2, then there's 7 spaces left, so I know there's 7 zeros. That's a good way to think about it, Lucas. All right. So, hopefully we get another few where we can practice this. They always started right here because that's where the original decimal was, all right? You see that right here? They started there because that's where the original decimal was. All right. So now, as we look at this one, Michaela, all right, 1.9. Now, looking at the exponent, Michaela, is my number going to be bigger or smaller? Okay, so we look at the exponent. Is the exponent negative or positive, Michaela? Negative. So we only did one of these that was negative, and it was Cruz. So you got to think way back to Cruz. So if there's a negative exponent, that's telling me something different. All the rest were positive. We were moving stuff to the right. If it's negative, we move stuff to the left. So if it's a negative exponent, it actually makes it smaller. Okay. Does that make sense, or can you remember that for me? All right. I didn't really give you a reason why it makes sense, so I feel bad about that. So, all right. So 1, 2, 3, 4, 5. So how many how many zeros do I add? 4 of them. Did my number get a lot smaller? Oh yeah. Mm-hmm. All right. And Michaela did that very well. Hopefully, if I can finish writing my problem out. All right. And we did get much smaller, right, Summer? Okay. Summer still there? Okay. All right. And we started between the 1 and the 9 because that's where the decimal was. All right. Now we move on. Connor, you there, Connor? All right. Awesome. So I get 5.09. I always start at the decimal, right, Connor? But now, is this number going to be bigger or smaller, Connor? Yep. Why are you saying smaller, Connor? Is my exponent positive or negative, Connor? Positive. So Michaela's was negative and it got smaller. Trenton's was positive and it got bigger. So if yours is positive, what do you think is going to happen for you? No, it's not. No, it's not. No, it's not. Because 10 to the 8th power is the same as 10 million. You're taking something times 10 million. Is it going to be bigger or smaller, Connor? Bigger. Anytime the exponent is positive, Connor, the number is going to get bigger. If the exponent is got a negative in front of it, then it's going to get smaller, okay? Yes, no, purple, you didn't hear that? Green. Okay, you did hear that though, all right? No, the exponent's positive, number's going to get bigger. Exponent's negative, number gets smaller. All right, so how many spots do I move it then, Conrad? 3, 4, 5, 6, 7, 8. So how many zeros does that mean I'm adding, Connor? 6 of them to fill in those loops, right? Mm-hmm. All right, well done, well done. So when my exponent is negative, Natalie, is my number going to get bigger or smaller? When my exponent is negative, Natalie, is my number going to get bigger or smaller? You may still be on mute, Natalie. Natalie still here? Okay. No Natalie. All right. So we get that there. Okay, and very good. We got a great answer of 509 million. Here's another nice page we can take a picture of if you would like. This kind of helps. For numbers greater than or equal to 10, use a positive exponent. So let's look at our first number right here, okay? 15,237. Is that bigger than 10? Yes, it is. All right. So if the number is bigger than 10, when we have our exponent, it's going to be positive. If our number is smaller than 1, we're going to have a negative exponent. Okay? So if we look at the starting number, so now we're going to go from regular numbers to scientific notation. Just before, we've been moving the other way. So if we look at our starting number, if it's smaller than 1, all right, hey, it's going to be negative. If it's, smaller than 10, it's going to be negative. If it's bigger than 10, it's going to be positive. All right? There we go. So let's move on. We're going to look at this number right here. First of all, Lucas, I'm going to come to you, sir. All right. So this number here, as I look at it, is it smaller than 1 or bigger than 10? Is this number right here smaller than 1 or is it bigger than 10? So my exponent, is it going to be negative or positive when I have my 10? Negative. All right. Now, our goal is to have one non-zero number to the left of the decimal. Okay, so we want one number that is not a 0 to the left of the decimal. So I start at the decimal. Where do I want to move my decimal to then, Lucas? One spot, 2 spots, 3 spots. Now, when we look at this, if I look, and I'm going to draw a black line, okay, maybe. Lucas put his decimal here. When I look this way, Trenton, is there only one number that's not a 0 on this left side? Yeah. Is there only one number over here that's not a 0? Like that's a 0, so it doesn't count. That's a 0, it doesn't count. That's a 0, it doesn't count, right? 7. So did Lucas put this in the right spot? Yes, he did. Very good job, Lucas. So now I can write this as 7.09, since Lucas put the decimal in the right spot, times 10. And Lucas said the exponent was going to be negative because that number was smaller than 1. But what is the exponent, Lucas? Do you remember how to get that? How did you get 3, Lucas? Oh, move the decimal 3 spaces. Oh, Lucas, you did a very good job there. Okay. So 10 to the negative third. Lucas's work showed a lot better. All right. Now let's go to Carson. Carson, I've got this number right here. Is this number smaller than 1 or bigger than 10? Okay, so since it's smaller than 1, Carson, is my exponent going to be negative or positive? Negative. All right. Now, where do I want to put this decimal at, Carson? Left or right of the 8? All right. So he wants to put it right there. So should I still count how many times I move it? Why am I counting how many times I move it? Oh, yeah. The number of bottom of the loops that we do. All right. So 1, 2, 3, 4. So 8.11. Is there only one space left of the decimal that's not a 0? Yes, there was. That's good. Times 10 to the, what's the exponent, Carson? Carson, I'm going to be mad at you now. 10 to the negative 4 because it was smaller than 1. All right. So Carson did a very good job of walking me through that. All right. He did a very good job of walking me through that. All right, let's go ahead and look at theirs. I don't like their work nearly as much as Carson's, so you can pause it there. Now, a pencil is 18.7 centimeters long. If you were to lay 10,000 pencils end to end, how many millimeters long would that be? Write the answer in scientific notation. All right. So they're going to have you do the math first to make the number big. Okay. So here's the big number that we're working with. I didn't make you do the math to make the number big. I don't want to be a jerk like that. Okay. But now I'm going to come to you, Miss Michaela. Is that all right? All right. 870. All right. And a 000. So, Michaela, in this number, where is the decimal, first of all? Because that's always an important thing. To the right of the 0. So I made that decimal black, okay? I did that on purpose so we could see it. Now, Michaela, is this number, the red number, is that bigger than 10 or smaller than 1? So I know my exponents are going to be positive or negative. If it's positive, if it's bigger than 10, it's positive. We've just been saying negative so much. So I know I'm going to have a positive exponent. Now, where does the new decimal go if I'm going to make this scientific notation? Amazing job. Between the 1 and the 8. So I would have 1.8. I need to write the 7. Do I need to write these other zeros that are out there then, Michaela? No, because they don't matter anymore because they're behind the decimal. Times 10. Oh, what did I forget to do? I forgot to go 1, 2, 3, 4, 5, 6. Okay. 10 to the what power, Michaela? How'd you get 6, Michaela? Yeah, counting how many spots we moved it, right? So, if the number's bigger than 10, it's going to be a positive exponent. If it's smaller than 1, it's going to be negative exponent. Very good job, Michaela. All right, so here's all the work. They're going to show like 7 lines to do the work Michaela did in like 1 line. Good job, Michaela. Now, an oil rig can hoist 2,400,000 pounds with its derrick, which is the name for the stabilizer. It distributes the weight evenly between 8 wire cables. What is the weight that each wire cable can hold? Write the answer in scientific notation. So they're going to make you do the math. Oh, 300,000 is what we're going to turn into scientific notation. All right. Now, I haven't called on Miss Proctor in a while. So, Haley, I have 300,000. And I'm going to ask you an important question, Haley. Where is the decimal in 300,000? Haley, you may still be on mute. Where's the decimal in this number? To the right of the 0. It's always important to know where the decimal is, because once we know where the decimal is, we can start. Now, if I'm going to do this in scientific notation, Haley, where do I need the decimal to move to or be? To the right of the 3. Very good. Because you want one non-zero to the left of it, right? Correct? All right. 1, 2, 3, 4, 5. All right. I counted that for you just because I like to count. All right. So now when you put this down, 3.0. It's always wise to put 1 0. Do I need to put the other 4 zeros, though, Haley? No. Times 10 to the... How'd you get 5th, Haley? Oh. There's 5 zeros behind it, or we can think 1, 2, 3, 4, 5 spots I moved my decimal. Okay? Okay. All right. There we go. Haley did it in 1 line. They do it in a whole page. All right. Now, a certain cell has a diameter of approximately 4.11 times 10 to the negative 5th. A second cell has a diameter of 1.5 times 10 to the negative 5th. Which cell has a greater diameter? So we need to look at these two numbers. I'm going to quickly write them out. and they want to know which one's bigger, okay? Times 10 to the negative fifth. All right. So 1.5 times 10 to the negative fifth. Okay. The first place I would always suggest looking would be at the exponents here, okay? Are the exponents the same in this one, crew? Or Bruce, are the exponents the same? Yep. All right, crew said yes. All right, sorry, Bruce, I didn't get you in here. So, Bruce, now we need to look at 4.11 and 1.5. Which one's bigger, Bruce? All right. So, which is the greater diameter? If the exponents are the same, the bigger number has the greater diameter. All right. Now we compared the powers, so then you look. 4.11 is the greater one. All right. Here we go again. All right. We've got 5. Excuse me. Times 10 to the negative third. And Christine, we've got 5.11 times 10 to the negative third. All right. So we look at the exponents first, Christine. Are they the same? All right. So which one is the greater? Wonderful job. You guys feel like you're ready to go? Let's cut you loose. I will be on here for the last 7 minutes answering questions. All right. Thank you all very much.